3M, we're on Financial Math Lesson 4, and we're going to talk about annuities today. This is a little bit more real life, perhaps. We've been talking about people's grandmas investing $1,000 for them, or somebody has $2,000 in an account. How much interest will they have in a few years? And a lot of us don't have $1,000 lying around or get really lovely lump sums from grandma. So most of us, when we're saving for things or paying things off, we do things on a more regular basis. For instance, most of your parents would pay a mortgage monthly, and that is called an annuity. So first definition, an annuity is a series of equal deposits made at equal time intervals. Much of the time that would be monthly. Please take a moment and write that one down. In math class, we're going to talk about an ordinary annuity when the deposits are made at the end of the time interval. So things happen towards the end of the month. And lastly, the total value of all the deposits at the end of the last time period is the amount of the annuity. So we're going to use that letter A for amount again, but this time it's going to be an amount of an annuity. I'll leave that for a moment for you to write it down. Okay. Suppose that you deposited $250 at the end of each year into an investment account that pays 4.5% compounded annually. So you're depositing annually and it's being compounded annually. What is the amount of these regular deposits after 3 years? So let me show you what happens. At the end of the first year, so let's just start, at time 0. At the beginning of our story, you made a decision. You're going to do good money things, okay? At the end of that year, $250 goes into the account. It's going to sit and sit and sit and sit, and we're going to figure out how much money that makes in a moment. At the end of the next year, another $250 goes into the account, and it sits for a while. At the end of the third year, you put $250 more in. We want to know how much is in that account. So the first deposit is going to make a little bit more interest than the second one. And the third one isn't going to make any interest at all. So for the first one, it's going to sit and earn the interest in the amount of, now I'm using compound interest because I see that word compound. So we have $250 and the rate is 4.5%. So I would do 1 plus 4.5%. And it is going to sit in there for 2 full years. The second one, I'm going to have my $250 and it is going to, I don't need a plus sign, sorry. $250 and it is also going to get 4.5% and it is going to grow for 1 year. And then I have another $250. Let's figure those out on our calculators. The first one is $273.01. The second one grows to $261.25. So the total after the 3 years is $273.01 plus $261.25 plus $250. We should have 4, 11, 18, 784.26. There is a formula for that, for putting all the bits and pieces together in one step instead of adding 3. This isn't so bad. But what if we'd had an investment where we saved every month for 50 years? That would take a lot of work. So we're going to give you a formula. So we are starting with A for the amount, just like we did in the last formula, but this is the amount of annuity. And what's going to give it away is that R for regular payment. So I'm going to put a star on that. As soon as you see an R for a regular payment, you know you have an annuity, something that happens over and over again for a certain time interval. A is still for amount. N is the number of compounding periods, just as we've seen before. And I is the interest rate. So we need to get that formula up onto our anchor charts and into your notes. And then we're going to do one that uses this formula. Just leave it for a minute so you can write it all down. Okay, suppose you make regular deposits into an account. You deposit $1,000 every 6 months into an account that pays 6% compounded semi-annually. What does semi-annually mean? Twice a year or every 6 months. So it matches how often you pay into it. Okay, what will the amount be after 10 years? So let's write our equation down. Square brackets, just to keep all my brackets straight, quite honestly. The amount of my annuity will be my regular deposits. How much do I put in? Is $1,000. My rate of growth will be 1 plus the interest rate, but the interest rate is compounded semi-annually. So I always write it off to the side. My interest rate yearly is 6%, and I want this semi-annually, so I'm going to divide it in 2. So that bank is going to give me 3% every 6 months. My N, the number of compounding, is 10 years, but it's twice a year. So I'm going to take my number of years and multiply it by the compounding periods is 20. They're going to put interest into that account 20 times. Subtract 1, square bracket, all over. Just the interest rate, not the 1 plus, just the interest rate, which is 0.03 semi-annual rate. Okay, now we have to type that ever so carefully into our calculators. Sometimes a really helpful strategy is to figure out the bracket first and write it down. I like to do it in one step because I have less rounding errors. But that's something we're going to practice today. Make sure that I help you if your calculator is not being friendly. The amount finally is $26,870.37. How much of that is interest? Well, the amount that you ended up with was $26,870.37, but how much of that money was yours? Well, you put $1,000 into the bank, 10 years, twice a year. So you put in $20,000 of your own money. So the interest that you get is $6,870.37, which is pretty cool. Can you tell that I'm trying to subtly get you to save money? Suppose you begin a savings program to have $2,500 after 5 years. You make a regular deposit every 6 months into an investment account that pays 5.5% interest compounded semi-annually. Calculate the regular deposit. So this one's a little trickier because they're asking us to find R. And we know that R is in the middle of the equation, so it's going to be a little ugly. I'm going to write the equation down one more time. The amount is your regular deposit times the interest all over I. Let's put in what we know. Suppose you begin a savings program to have $2,500. So we want the amount to be $2,500. I want to know what R is, so I'm going to have to solve for that in a minute. My interest rate is 5.5%, and it is compounded again semi-annually. So I am going to figure out what I is off to the side. My yearly rate is 5.5%. So that's how I would write 5.5% as a decimal. I want to make that a semi-annual rate, so I'm going to divide it in half, which is 0.0275. So 2.75% twice a year. 1.0275. Now I've got to be careful with my N. I'm going to do this regular deposit for 5 years, but it's semi-annual. So my N value would be 5 years times twice a year. There will be 10 compounding periods. So 10 subtract 1, mismatched brackets, sorry, and then just the 0.0275 goes on the bottom. Okay, I need to solve for R. What do we do first to get R by itself? My first strategy would be to multiply both sides by 0.0275. If I do that to both sides, I get rid of that denominator. So I would have 687.50 equals R times 1.0275 to the 10 subtract 1. You could put that extra set of brackets in if you want. It doesn't matter. Now I want to get R by itself, so I'm going to divide both sides by ugly bracket. So left side will look like 687.50 divided by 1.0275 to the 10 subtract 1. Be careful with your calculator, but we're going to do that division, and make brackets your friends. You should get $2,205.99. That's funny. I don't know if you caught my mistake or not, but that answer doesn't make sense because on my calculator I had an extra zero here. I did 25,000. How much would I have to put in? Let me just fix that quick. Okay, there we go. It was 68.75, so I had the decimal in the wrong spot. And I divide by that interest rate, which gives you $220.60, which makes a whole lot more sense. So you're going to put in $220.60 10 times, and you'll end up with $2,500 in your account.